In this section of this laboratory, we're actually going to replace the original solution with the new solution to update of our characters. So let's take a look at this. So we're going to once again stop our debugging session. Actually, I have already stopped, I guess. And we're going to just copy and paste a new version of the code, which does the same thing. Okay, so here let's examine the code that we have, and in the first line we have this move instruction, which moves the value of the address of the first character into register EDI, right? So EDI stands for Extended Data Index. So we'll just use it as a basically pointer to the first character in memory. So it has the address of this character in memory, because offset is the operator that essentially tells the assembler that look, we have this label in the data segment and we would like to take its value, its address, and load it into our register. Okay, so next step is to load AL with 58H. Of course, this is if you want, and by the way, part of this requirement here is to add comments. So here I just suggest that you just start documenting it, that load address of characters, or we can just say address of character A, right, into register EDI. Now notice in assembler you can use lowercase or uppercase names of registers. It's just a style matter. It doesn't really change anything. So is with these operands right here. So I'm just trying to use a consistent style. So then we move into register AL. Okay, here I just think that this is one of the possible challenges to be able to document everything. And here we say that register AL equals, this would be the value of character X, the encoding of character X. Right, so that's just like a pseudocode of what we do with this move instruction. Then we have this update label to which we're going to be jumping. So essentially right here, this is a loop. At some point we're going to be doing some comparison and then jumping back to this label conditionally. We'll talk about this. So the next step is that essentially we update the memory, right? So EDI equals AL. I guess this is the best way to document it, just to obviously the pseudocode. I'll try to use uppercase version in the pseudocode, that this memory location, right, pointed by EDI, is getting updated by the value in register AL, so which effectively moves character X right here. So we're replacing this with character X. So you can add more comments if you'd like. Now, of course, we're incrementing EDI, and the comment here could say that we can say update address to move to the next character, something like this, whatever. So basically we're maintaining the address inside this loop that we begin with this label, and we're incrementing EDI. So of course after incrementing it the first time, EDI will be now pointing to the next character in our memory. We're also incrementing AL So by incrementing AL, we're preparing next character, and the next character will be character Y, because if you take character X and increment it, it will become next character in alphabetical order. So it will be Y, then it will be character Z, and then it may continue to increment these characters if our loop continues. And then we compare AL with 5AH. Of course, 5AH is the encoding of character Z, and therefore we can use the pseudocode here that says if. Now remember that compare instruction is like subtraction. Basically, it takes this register value, which is 8-bit size register, and subtracts this 5A hexadecimal from it. So if the values are the same, compare will set a whole bunch of flags to indicate that the characters are the same. Or they can be compared in other ways, greater or less, or greater or equal, and so forth. So here we say that if AL is less or equal character Z, right? So this is the actual 5AH is the value of the encoding of character uppercase Z. And the reason why I use this pseudocode less or equal, because the next instruction says update. JLE stands for jump if equal, right? So JLE mnemonic stands for jump. It's a conditional jump if equal, or we'll say jump if less or equal. So if this condition is true, and our next character that we just prepared is less or equal character Z, we're going to jump back to this label update. And look, we already updated EDI to point to character B. We already incremented character, so now it's character Y. So of course what's going to happen here is that because EDI now points to this memory, and of course AL contains now encoding of the next character Y, so character Y will be placed in place of character B, right? So this will become character Y as a result of this next loop iteration. And then we increment our address, we increment our character, we make other comparison. It's AL is now equal Z, so we make another jump, right? So from here we jump again, and we make our next update. So of course character Z will be stored in this location. The next time we increment the character, and it becomes whatever the next character is in ASCII encoding table. So this condition becomes false, and if this is false, JLE will no longer jump, so we just fall through, and the next instruction to execute will be a return instruction, which will return us back to the caller, which is the operating system that is trying to make a call into our program. So this will be all over. So clearly the logic behind this set of instructions, this new solution, is the same. It basically is to create a loop which one by one will update characters in the original character positions where the ABC originally was placed by the linker right here. So this is what I want you to do here, and I guess if you copy and paste this with comments, I expect you to make a comment of everything. So this will be the idea, is that we want to be able to add comments to every line. And so we will just follow up on this in our next video.